Welcome to the stage, Peter.
Thank you very much. Right, so this will be a challenge because I've had to rejig slides here because they weren't coming out properly, so hopefully it'll work to our advantage, but we'll see how we go. So, because I won't see them here, that's the problem. Excuse me, this isn't moving forward? Here we go. I won't see them here. Right, okay. I'm Peter Wilson. I set up 5 years ago the Mass Timber Academy with colleagues because although we've been using modern timber technologies like cross-laminated timber, glulam, LVL, and so on for a number of years, our universities still don't teach architects or engineers or anybody else about any of these materials. So although we're using them, people don't know a hell of a lot about them. And so we find all kinds of issues arise and so on. So what I want to talk to you about is, let me just see. Right, okay, that's me. The middle thing there saying laminated wood. I ran a conference on this in 1999. So for 25 years, I've been involved in this, in research and development, looking at innovation in the use of mass timber in construction, and talking to all kinds of people. We run courses for architects, engineers, building control officers, all sorts of things to teach them about this because the technology is not quite the same as other things. So, I've written hundreds of articles, books, all sorts of things on the subject. So there's plenty of information out there. If it's new to you today, okay, we'll crack through it in 20 minutes. And then, because the reason we want to do that is to say the world is changing. The world is changing very fast. And our towns and cities are becoming more densified. People are moving from the countryside in lots of countries into cities. Land becomes incredibly valuable. We end up building upwards. And we build upwards now in timber, not necessarily in steel and concrete, because for all sorts of environmental reasons, things have changed. And I'll tell you more about that. So really what we're looking at is saying, what does this affect us? Now, this is the reason, because the low carbon future, we're really serious about it, and whatever dates politicians set for it, how do we achieve it? And we're not achieving it the way we're going about it at the moment because we have an energy crisis, we have a climate emergency, Brexit, post-COVID, cost of living, but in the UK we also have damp condensation, poor thermal insulation, poor air tightness, poor construction quality, and inappropriate use of materials. So, lots of things to consider, lots of things to get right, and for the PCA members, lots of things to earn income from. Way back, 2016, Mark Farmer wrote a report for the government, Modernise or Die, and it was absolutely jaw-dropping in terms of saying, if we don't change things, if we don't change the way the industry works, if we don't change the way we use materials, and if we don't train people in the skills necessary to do these things, we have no hope. 2021, in the subsequent report, nothing had changed. And this is true throughout the UK construction industry. For years, Latham, Egan, all these kind of reports came out saying we need to change. Nothing changes unless legislation changes. That's the reality. When legislation changes, everybody in the industry decides they need to know and need to get on with things. But without it, you can't expect much to happen. And so we have a problem because if we're going to, by 2026, achieve many of the things that were in Mark Farmer's report, we really have a lot to do. So why mass timber? Now, mass timber, I'll explain what that is in a minute. But there are new imperatives. I mentioned some of them already. Circular economy, yes, of course. Use of renewable materials. Timber is number one in that kind of world because we can grow more timber. Off-site manufacture is certainly more and more important to get accuracy, to get precision in building, to get speed of building, and less deliveries on site, all sorts of things. And locally grown timber. This is something I've been working on for many, many years to say, how do we make more use of UK grown timber? Because you may or may not know it, but we import more than 80% of our construction timber. We are the second biggest importer of timber in the world after China. Now this is really crazy. We grow a lot of timber, but we need to make better use of it, and we need to understand it better. And this is why, because you can see the growth here in the market for mass timber. These are two charts looking at just CLT alone, cross-laminated timber alone. But the market internationally is growing phenomenally. It's not so much growing phenomenally here because Grenfell set everything backwards. Regressive legislation after that affected timber more than anything else, although there was no timber in the building. But that's the way regressive legislation works. So what is mass timber? What do we mean by it? So I've shown 5 examples, 5 different systems here. Nail lamination, dowel lamination, these are non-glued systems. Glued lamination, you'll have come across glue lam, I'm sure. Some of you might have come across cross-laminated timber, and less so probably laminated veneer lumber, LVL. Now, there are different characteristics to each of these things. I'm not going to go through that. I'm just going to show you some of them. Nail lamination, that's basically how it works. Stack board on board, stick nails in. I'm working on a project at the moment to use wooden nails, so we don't use any steel at all. And there's a whole world of what we're trying to do with wooden nails. I won't bore you with that. Dowel lamination, it's kind of the same thing, but we drill holes and put hardwood rods into softwood. The difference in moisture content means that they lock together once they reach equilibrium moisture content. Glue lamination, you've probably come across it, but there are lots of different types of looking at straight, curved, interlocking, blah, blah, blah. It's all up there. Some fantastic buildings emerging here in Britain and around the world, really pushing these technologies forward. And cross-laminated timber, this is just one example, but you might see it as just something new, something that's a fashion item that, well, we don't need to know about it. You do need to know about it because it's the fastest growing construction product, I think, anywhere in the world at the moment. And then laminated veneer lumber. So I'm showing you sort of extreme examples of what's being done with these technologies. There's a lot of simpler buildings around, but these are the ones that I think are pushing the boundaries, pushing the research, pushing the technology. And there are lots of reasons, advantages, benefits for using these products. I've listed some of them there. I'm not going to read them all out because I've only got 20 minutes, and if we want to get out before it's dark, we'll need to crack on. So, and there are plenty more properties, but I think reduced weight of the buildings, reduced deliveries to site, carbon sequestration is a big part of it in terms of locking up carbon for the future. Very high air tightness standards, very good thermal efficiency, and this came up earlier talking about schools and so on, and I wanted to put this in to say, when you expose mass timber surfaces, big thick panels of wood, but you leave the surfaces exposed, you get the benefits of wood's hygroscopicity. You get the wood kind of absorbing moisture, releasing moisture, very good internal air quality. And this is true in schools across the country. There's been lots of schools built and nurseries built. This one happens to be in Edinburgh, but lots of them around the country where the exposed timber is very beneficial for children's health. Teachers and childcare people are constantly reporting that children are calmer, they're absorbing information more effectively, and so on. So the nature of the materials we use changes the kind of environment that people live and work in. And there are lots of carbon benefits. I'm not going to run through this because this is more this is for kind of consenting adults only about how you construct the buildings. So we won't bore you with that. I do courses in that. That's quite separate. But what is cross-laminated timber? Basically, we take strips of wood, we put them together, we glue another layer of them at right angles to it, and so on, until we build a panel. And you can see some examples of these here. I haven't got a pointer. I don't think, oh, I do have a pointer. Whoa, hey, excitement. So these are different layups of, you usually have odd numbers so the outer faces of the panel, timber faces in the same direction. I'm not going to give you a whole lecture about this, just to show you some examples, because when we come on to it later about issues for PCA members, you'll see different types of things here. Now, if I go back one, you'll see here these are glued down those kind of lines. They're not necessarily glued across where the wood crosses, and we'll come on to that. In this example, they do get glued across there as well as across there. That's important, and I'll come back to that. And first CLT building in the UK. People keep telling me, people in the industry who've never used it and so on, goes, well, this is new, this is risky. We've been doing it for 25 years. It's not new, it's not risky. In fact, when people use it and they begin to realize how efficient it is, they become kind of evangelical about it, maybe too evangelical. Excuse me, I'm looking around here. Oh, what is it? Oh, can of water. Who knew? Give me one moment. Got to keep going, 20 minutes. So it's not a new idea either. It's been around since 1923, so 100 years when it was first patented in the United States. Unusually for the United States, they didn't take it much further at the time. They're going at it like a dog at a bone now. They're building factories everywhere and building huge amounts of buildings, particularly tall buildings in mass timber, all over the States, changing the legislation from state to state to encourage more timber building. We've done it the opposite way around. We want to discourage it, at the moment, and that's really not the way the world's moving. So basically, you see how it's constructed. Wall panels, floor panels, basically platform frame construction, for those of you who are interested in that. Stability, you can see in this example, this was the first tall timber building in the world for residential structures. It was 9 stories in London, East London, and it's kind of honeycomb structure, so the loads are all distributed, so it doesn't suffer from a thing called progressive collapse, where that to happen. It's a very efficient structure, but this changed the world. Around the world, as soon as this was built, way back in about 2012 or so, maybe a bit earlier, engineers started looking at it and designing 25, 30-story timber buildings. And that's the way the world is moving now. We're seeing buildings that are more than 20 stories high, purely in timber. And then, the elephant in the room, Grenfell. You can see, as I said earlier, there wasn't any timber in Grenfell, but the legislation that came in England and Wales said 18 metres above that, the whole wall thickness, the whole wall construction needs to be non-combustible. Now, for those of you who understand that kind of nature of building construction, you realise how laughable that statement is, to get all the layers in a wall to be non-combustible. But this is 10 stories in London, and London was leading the world in terms of tall residential structures. Solid timber, everything there is solid timber. And then Grenfell changed things, and we began to realize that we have different areas of construction in terms of timber. We have low and medium-rise buildings, high-rise, distinct structural technologies in terms of lightweight structures or mass structures. 3 risk groups, because different things need different kinds of consideration in terms of insurance. But the particular things we're talking about here, susceptibility to fire and moisture, durability and repair, concerns over quality of design, concerns over competency. This word comes up all the time. And that's partly goes back to what I said earlier. If you're not trained in it, you're not competent in it. And that's what we need to change. So, but the regulations that came in, and I keep hearing it from people, well, we can't build higher in timber. The regulations only affect residential structures. They don't affect commercial structures because those are still happening, and they're happening taller. So there's a kind of contradiction there, but I'll leave that with you. And most recently in London, hardwood laminated veneer lumber. This is a frame that's completely made of hardwood. Laminated veneer lumber is little thin 3mm strips assembled like glue lamp, so all the wood runs in the same direction. But this is in the centre of London, and when you think that the London Building Acts are predicated on the Great Fire of London from 1666, and after that timber was kind of outlawed, we're back in it now because it's the fastest, quickest way to build and build effectively in very compact sites because you don't need huge amounts of storage space. You're building very quickly. And you're building very efficiently and very accurately because you're within 1 or 2 millimeters precision in terms of the structure. But then we're talking about tall timber buildings around the world, and they're going up everywhere. And so you have to be cognizant of the lessons to be learned from that, the things to do with fire regulations, things to do with fire mitigation systems, and so on. There's a lot of research now, huge amounts of research in all of this. Then we move on to durability, and you get buildings that are hundreds of years old that are still standing, made of wood. But we're looking at it from a different kind of thing, because those of you, and all of you, I think, in the room, are aware of moisture movement in timber, so I'm not going to linger on that. The important thing is not to let the wood get wet. That's just standard. But we have different things that affect wood, and you can see here, we have plenty of moisture level. It's over 20%, you have a problem. Temperature and oxygen, that all affects it. And we get long-term exposure. Now, I put 2 slides here because one of the things that's interesting is when you cross pieces of wood like this, you will find at the crosses, moisture can penetrate between the strips of wood and down into the next layer and down into the next layer. Once the moisture's in there, it's very hard to dry out, almost impossible. And so we need to look at, but I've put this slide in because I mentioned it earlier, because you can see here the gaps that begin to emerge, slight shrinkage, but the panels themselves are dimensionally stable. In this particular example, there are no gaps, so there's no possibility of water getting into the body of the slab itself. It might happen between where they connect to each other, but there are details to solve that. End grain areas, we know we have to treat them because that's where the moisture gets in. So, but then when you see it on site and you see the problem when contractors have no experience in doing these things, they don't clear the water away quickly, they just let it seep in, or they sweep it to another area and just make that area wet as well. So that's the start of the problems. Then you see what the issue is when you actually leave it and let it get damaged, because you have a whole series of things that happen with water exposure and what we need to do to mitigate that and what we need to do to be aware of it in order to prevent it happening. And part of that is now we're looking at really whole series of things that happen in the design phase. What happens when wood gets wet and continues to get wet, or the moisture is retained within the structure, either because the follow-on trades don't understand it particularly, so they'll put down a roofing membrane on top of a wet slab, seals it all in, you can't dry it out, and what you get is internalized rot, and then you get into big repair bills because you're having to really take the building apart to solve the problem. Moisture risk management, there's a whole series of things here that can be done, and I've mentioned a few of them. But the big thing really that we're looking at and what to talk about today is this, moisture management plans, because that really is becoming the most important thing now. At the beginning of construction, the contractor not only has to have a proper moisture management plan for the whole building operation, but also that they effectively impose it on all the subcontractors so that they understand their role in the sequence of construction, not to seal in moisture. And these are really the stages of a moisture management plan that, and I think it's something from a point of view of PCA members is to think, this is an area of work that is coming for you. If you're not already involved in it, it's coming. And it's coming, so where are the opportunities or the things that require your skills and services? And really advising on, for a lot of contractors, big or small, it's really what you need to do to develop a management sequence that makes sure you're building effectively. There's a whole thing, a range of things here. I'm just flashing them up very quickly here because I see a man looking at me and saying, "Woo, time." Yeah? He's in denial. So, talk about the future. There's a whole series of things that are happening. The whole thing about mitigating climate change and so on is we're having to look at different materials, different ways of constructing buildings, different ways of making sure we're using renewable materials, making sure we can do things in a way that helps decarbonize the environment. And I mentioned earlier about the whole way in which wood sequesters carbon. As I said, there's a whole... I'm condensing about 25 different courses into one 20-minute session here, so forgive me. Because I think the point about this is when we're repurposing existing buildings, we're also looking at mass timber interventions or additions to buildings. We're seeing quite a lot more now of existing buildings with 2 or 3 extra stories in timber because they are lightweight, so you can build on the existing foundations without having to underpin buildings and so on. So there's a lot of different things happening. A lot of, I would say, more research and development is going on now in this world than in, say, steel and concrete, because huge amounts of stuff's already been done and all of that. I see it with PhDs and see it with theses for universities and so on. You think, oh, not another thing on an area of concrete that's already been done, but it's just happening everywhere. That's what engineering courses do. Whereas in this world, and it's particularly with European universities, what they're doing at scale in terms of the research and development facilities they have is phenomenal. And it's leading, really pushing the boundaries of the technology and what we can do with it and what we can do safely. I think I've cracked through it pretty quickly there, but we have lots of courses we do in all sorts of things, and I'm happy to do courses for PCA if they want to find out more about all of this, because I think there's a huge area of issues that depend on the kind of services that your members provide. So on that merry note, I'll stop there, say thank you, and look forward to questions. So thanks very much.